is leading the initiative with continued participation by NASA. The Boeing Company is the prime contractor. And just a few moments ago, the team received its final weather briefing and was told weather was within the launch commit criteria for today's launch. Current weather conditions are as follows. Probability of violating weather constraints are 30%, mainly due to the risk of cumulus clouds in the area and ground winds. However, both are within constraint. We had issues yesterday with both cumulus clouds and ground winds, but today we're within the constraint. Ground winds are have been consistently for 3 to 4 hours within the constraint, and cumulus clouds also look favorable. So upper level winds are within the constraint. It's 71 degrees Fahrenheit here at Cape Canaveral, and from the weather outside, it looks like a good day for a launch. So the team is go for liftoff with T0 again now planned for the open of the second window at 5:46 p.m. Eastern Time, and again that's a 10-minute launch window, which will close at 5:56 p.m. Eastern Time. This afternoon's flight is the 24th launch of the Atlas V and the third flight of the 501 configuration. The Atlas V 501 is powered by the RD-180 main engine and a single-engine Centaur upper stage. The spacecraft is encapsulated within a 5-meter diameter payload fairing. Today's launch is the culmination of many years of hard work by the combined Air Force and ULA team. The encapsulated payload fairing was mated to the Atlas V booster on February 21st, as you can see here for those of you watching the live launch broadcast. And this is a video taken on the 21st of the OTV spacecraft encapsulated inside the 5-meter payload fairing being mated to the Atlas V vehicle. Early in the afternoon on Thursday, day before yesterday, the fully integrated Atlas V was rolled to the pad at Space Launch Complex 41. The Atlas V is prepared for launch at the Vertical Integration Facility, or VIF. And the VIF is located 1,850 feet south of the pad at Space Launch Complex 41. A trackmobile is used to transport the Atlas and its mobile launch platform to the launch pad. The Atlas V rocket stands 196 feet tall and weighs 76,190 pounds when it's rolled to the pad. Fully fueled, the rocket weighs 757,380 pounds at liftoff. And this is Atlas Mission Control at T-minus 4 minutes and holding. The animation we'll see after liftoff is referred to as STK, or Satellite Toolkit. STK uses telemetry data to track the flight beyond the range of ground-based tracking cameras. STK is a three-dimensional representation of the launch vehicle's trip into space. And today's launch begins yet another unique mission for the United States Air Force. The following video provides an overview of the launch phase of the mission and incorporates the STK animation that I just described.
The following profile details the important events of this mission using approximate times. The Atlas rocket will launch the Second Orbital Test Vehicle, or OTV-2 mission for the United States Air Force.
This is Atlas Mission Control at T-minus 5, 4, 3, 2, 1. And the RD-180 engine roars to life and liftoff.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. At 51 seconds into flight, the vehicle begins a zero angle of attack flight through maximum dynamic pressure. At 90 seconds, the vehicle experiences maximum dynamic pressure. The Atlas V is now traveling at Mach 1, the speed of sound. At 100 seconds of flight, the RD-180 engine is throttled down to 95%. The payload fairing is jettisoned 3 minutes 37 seconds into the mission. Upon reaching 4.6 Gs, after approximately 4 minutes, the RD-180 engine begins a ramp throttle profile to maintain a constant vehicle acceleration. Approaching booster engine cutoff just over 4 minutes into flight, the Atlas V is burning propellant at a rate of more than 1,500 pounds per second, more than 110 statute miles in altitude, 148 statute miles downrange, and traveling at a speed of more than 9,600 miles per hour. Booster engine cutoff occurs at 4 minutes and 23 seconds. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. Centaur main engine cutoff occurs approximately 17.5 minutes into the flight.
This is Atlas Mission Control at T-minus 4 minutes and holding. Preparations for launch are continuing. Today's launch is dedicated to the memory of ULA employee Jose Godani and retired Air Force Colonel Larry C. Jackson. During his 21 years of service, Jose was a key contributor in the fabrication and development of Atlas II, IIA, Atlas III, and Atlas V launch vehicles, and a valued resource in the area of structural assemblies for the Harlingen production facility. As a senior assembler, Jose worked on a variety of Atlas structural products. Jose's expertise in the fabrication of skin stringer structures contributed to the successful fabrication of Ford adapters and boat tail products. Jose's commitment to mission success, quality, and integrity, along with his desire to help others, will be sincerely missed. One of the giants of the space industry, Colonel Larry Jackson's distinguished career spanned 28 years in the Air Force and 17 years with Hughes and Boeing. His Air Force assignments included engineering and program management roles on the Titan III and Minuteman programs, as well as the Millstar Space Segment program. In his second career, he held roles related to the integration and launch of nearly 20 satellites for Hughes and Boeing, including 11 UHF follow-on satellites launched on Atlas rockets, and most recently 3 GOES satellites launched on Delta rockets. Today's launch is also dedicated to all current and former members of ULA's San Diego production team. Atlas and Centaur development and production in San Diego had a profound impact on the local community and the entire nation. Through hard work and dedication, these men and women truly earned a place in the history of American space exploration. Although the facility is closing, the San Diego workforce leaves behind a proud legacy. The history of their work will live on at the San Diego Air and Space Museum. ULA plans to donate models, displays, and photos from Plant 19 to the museum so everyone can see the importance of their work. ULA is also issuing a grant to the museum to help create an Atlas V exhibit. This is Atlas Mission Control at T-minus 4 minutes and holding. Launch conductor Ed Christensen will be polling the team in just a few moments for the final go to resume the countdown. 28 launch managers and engineers are polled for their readiness status to proceed with the launch. This is the final status check before launch for all launch vehicle systems, including the vehicle's hydraulics, pneumatics, propulsion systems, flight control, electrical systems, and propellant systems. The team will verify that the ground systems, including the computer-controlled launch system, telemetry, propellant transfer systems, are all ready for launch, and the team will verify that the Eastern Range operations, the weather, and the space vehicle are ready for flight. Some of the final processing steps prior to launch include completing propellant topping of the Atlas and Centaur stages and securing the vent valves of both stages. The team will switch the vehicle from ground facility power to internal battery power, and they'll verify the pad water deluge system is ready for liftoff and conduct the final checks of the vehicle's propulsion systems and propellant systems So let's listen in as Ed Christensen performs the final polling of the team to verify readiness for launch.
Status check for continuing the countdown. Atlas systems, propulsion, go. Hydraulics, go. Pneumatics,
Go.
LO2,
Go.
water,
Go.
Centaur systems, propulsion, go. Pneumatics, go. LO2,
Go.
LH2,
Go.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
instrumentation,
Go.
comm,
Go.
CC cubed,
Go.
umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
OSM,
Go.
ULA safety officer,
Go.
range, weather, and final clear to launch.
Go.
Launch director,
Launch director is go.
proceeding with the count.
This is Atlas Mission Control at T-minus 4 minutes and holding. And as you just heard, polling is now complete. The team is given the go for launch of the OTV-2 mission at 5:46 p.m. Eastern Standard Time. We'll be picking up the countdown at T-minus 4 minutes and 1 minute 55 seconds. From T-minus 4 minutes until launch, you'll be listening to the launch conductor and his team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure Atlas LO2 topping. At T-minus 2 minutes, the team will transfer Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 58 seconds, the team will secure Atlas battery heater power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start. At T-minus 1 minute 50 seconds, the team will secure Centaur LH2 and LO2 topping. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable. At T-minus 1 minute 38 seconds, the team will secure Centaur battery heater power. At T-minus 1 minute 37 seconds, the team will arm the flight termination system. And 59 seconds away from picking up the count. At T-minus 40 seconds, the Centaur tanks will be stable at flight pressures. A final propellant status check is conducted at T-minus 25 seconds, and at T-minus 3 seconds, booster engine starts. Vehicle motion occurs at T+1 second. 38 seconds away from picking up the count. It's 20 seconds to pick up the count.
On my mark, time will be T-minus 4 minutes and counting. 2, 1, mark, T-minus 4 minutes and counting.
This is Atlas Mission Control at T-minus 3 minutes, 45 seconds, and counting. The launch vehicle, spacecraft, ground systems, and weather are all in a go status, and we're moving towards T0 at 5:46 p.m. Eastern Time. Once the vehicle lifts off, it will take about 90 seconds to reach Mach 1.
Atlas takes flight pressure. Carrying LO2 topping.
250. FTS internal.
Two minutes and 40 seconds.
Spacecraft on internal power.
Roger.
159.
Vehicle internal.
Launch sequencer start.
Securing Centaur LH2. Securing Centaur LO2.
140.
Launch enabled.
FTS armed.
90 seconds.
Orc is armed.
STS count started.
115.
Reduce ACS for launch. Roger.
And we're now inside 1 minute, 55 seconds and counting. "45 seconds.
40.
Stable at step 3.
That valve's locked. ECS reduced for launch. Roger. Steps check.
Go Atlas.
Centaur.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. Atlas engine ignition, 0, and liftoff of the United Launch Alliance Atlas V rocket, carrying the second OTV mission for the United States Air Force.
Vehicle's cleared the MLP. Pump speeds are good. Injector pressures are within parameters.
You're hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Pitch program has begun. Vehicle response looks good. Tank pressures are stable. Bus battery voltages are good. Booster engine continues to operate well. Pump speeds are stable. Injector pressures are good. Begun flying the zero angle attack phase of flight. Pitch program's complete. Booster PU has gone to closed loop control. The engine response looks as expected for the set mixed ratio. Current altitude is 3.5 miles. Downrange distance 0.3 of a mile, traveling at 1,186 miles per hour. Mach 1. Max Q. And boosters throttled back, right on schedule. Engine response looks good. Pump speeds are as expected for the set power level. Begun flying the zero angle attack, alpha bias stern phase of flight. Steering response looks good. Coming up on closed loop steering. And closed loop steering has been enabled. Some small body rates, but continue to control right down the middle. And we have the RCS pyro valve firing. Systems pressurizing to flight levels. We have also begun to throttle back to 2.5 Gs in preparation for payload fairing jettison. current altitude is 47 miles, downrange distance 46 miles, velocity is 4,048. Coming up on payload fairing jettison shortly. And we have payload fairing jettison right on time.
This is Atlas Mission Control at L plus 5 minutes and 1 second into the flight. And we've just heard Marty Malinowski report the successful execution of events comprising the early part of this evening's mission. All systems continuing to operate nominally. The vehicle performing as expected. Atlas vehicle performed as planned. Payload fairing, jettison, and BECO events and main engine start number 1, the first burn of the Centaur upper stage, each occurring as expected. Our next event will be the Centaur main engine cutoff, which will occur just over 17 minutes elapsed time into the flight, which is about 12 minutes from now. So while we have an extended period during this first Centaur burn, we'll pause and then resume commentary in about 10 minutes. So again, the flight progressing as planned, liftoff occurring as scheduled at the top of the second window at 5:46 p.m. Eastern Time, and the vehicle continuing downrange. Right now, the vehicle is at an altitude of 159.
Adjust security roadblocks
miles,
for PATA.
and distance downrange is 398 miles. Downrange from Cape Canaveral, traveling at a velocity of 9,839 miles per hour. So the mission continuing as planned. We'll pause for a short while and return at the end of this Centaur first burn for the main engine cutoff number 1 event in about 10 minutes. This is Atlas Mission Control. This is Atlas Mission Control at L plus 15 minutes, 4 seconds into the flight. Launch of the Atlas V OTV-2 mission for the United States Air Force occurred at 5:46 p.m. Eastern Time. And the countdown is relatively nominal. The mission is currently continuing as expected. The vehicle is in the Centaur first burn. Centaur upper stage first burn will continue for the next couple of minutes. The vehicle right now is at an altitude of 194 nautical miles and 2,138 miles downrange from Cape Canaveral, traveling at a velocity of 15,495 miles per hour. Again, our next event is main engine cutoff, or MECO 1, and it's scheduled to occur in under 2 minutes. So we'll go back to Marty Malinowski and listen in for the continuation of the mission and MECO 1 event coming up very shortly. So that event has occurred as expected. At the request of our customer, we'll now conclude live coverage of the OTV-2 mission. I'd like to thank Marty Malinowski for his play-by-play of key launch and mission events. For more mission information about this launch and the Atlas V vehicle, please visit our website at www.ulalaunch.com. And this now concludes our live coverage of the Atlas V OTV-2 launch. We'll leave you now with one final look at liftoff. I'm Don Spencer. Thank you for joining us and have a great evening. 5, 4, 3. Atlas engine ignition, 0, and liftoff of the United Launch Alliance Atlas V rocket, carrying the second OTV mission for the United States Air Force.
Vehicle's cleared the MOP. Pump speeds are good. Injector pressures are within parameters.
You're hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Pitch program has begun. Vehicle response looks good. Tank pressures are stable. Bus battery voltages are good.